Let us see now partial differentiation. So what is ordinary differentiation? When z is function of x, ordinary differentiation. When z is function of x comma y, when z is function of x comma y comma t, when z is function of x comma y comma r comma s comma t. So when z is function of only one variable, it is ordinary differentiation. Here we have ordinary differentiation. When z is function of more than one variable, partial differentiation comes, okay? When z is function of only one variable, ordinary differentiation comes. Here when we differentiate z with respect to x, we say dz by dx, which is f dash of x, okay? Here when we say differentiate z with respect to x, we have to add the word partially because we have more than one variable, right? So when z is differentiate z with respect to x partially, so we write dou z by dou x. Here we have only one variable, that's why ordinary differentiation dz by dx. When we have more than one variable, it is partial differentiation comes dou z by dou x, dou z by dou y. So we differentiate z with respect to x partially. What is the meaning of the word partially? See, partially, keep other variables constant. The meaning is keep other variables constant. That is differentiate z with respect to y, differentiate z with respect to x, keeping y constant. Instead of writing keeping y constant, use the word partially. Okay, partially replaces many words. Differentiate z with respect to x partially. Okay, and so we use dou z by dou. See the dou, the pronunciation dou z by dou x, dou z by dou y. Okay, so when here you see I said z is function of one variable, and this variable is independent variable. Independent variable, and this depends on x, so it is dependent variable. Dependent variable. It is independent variable. For example, z is function of x square. Function of x, let us consider x square. So z depends on x. When x takes 2, z is 4. Z is 4. When x takes 4, z is 16. Okay. So z depends on x, whereas x is independent. That's why this x is called independent variable and z is dependent variable. Okay. So when z is function of only one independent variable, ordinary differentiation comes. When z is function of more than one independent variable, partial differentiation comes. Okay. So you should know these two variables, independent variable and dependent variable. You should know both. Okay. So here z is dependent, x and y are independent. When there are more than one independent variable, then partial differentiation comes. Okay. So like ordinary differentiation, when z is x square, right? When you differentiate with respect to x, we know x to the power n formula. Differentiation of x to the power n formula, which is n into x power n minus 1. 2 minus 1 is 1. 2x, right? When you differentiate it again, d by dx of dz by dx, d by dx of 2x. You know, when constant is with function, take constant outside. Dx by dx is 1. Okay. This is d square z by dx square. Okay. Second derivative. Similarly, you can go third derivative, fourth derivative. Okay. Here you can see, let us take example z equal to x square plus a into y square plus b. Z is function of two variables, independent variables, x and y. X and y are independent, z depends on them, so z is dependent. Okay, let us differentiate z with respect to x partially. Dou by dou x of x square plus a into y square plus b. Differentiate with respect to x partially. When you differentiate with respect to x partially, this y is constant. Take the term outside. Since it is a multiplication in between, you can take it outside. Now differentiate x square plus a. Differentiate x square plus a, which is 2x, right? 2x. Differentiation of x square is 2x. Differentiating a 0. Okay. So answer is 2x into y square plus b. Okay. And when you differentiate it again, dou by dou x of dou z by dou x, which is dou square z by dou x square. I have to differentiate again the answer with respect to x partially. So you can take 2 constant outside and y square plus b constant outside. So other variables are treated here as constant. Differentiate x with respect to x, which is 1. So this is second derivative, which is denoted by dou square z by dou x square. Okay. Dou square z by dou x square. Similarly, if you want, you can go further derivatives. Dou cube z by dou x cube, etc. Okay. So when in case if it is in between plus, instead multiplication, in case let us take x square plus a plus y square plus b. Instead multiplication when we have addition between. Differentiate z with respect to x partially. This becomes 2x, this becomes 0, this becomes 0, this becomes 0. Because when we differentiate with respect to x, y is constant. Already these two a and b are constants, okay. We call as arbitrary constants or simply constants here. You take constants. We shall discuss arbitrary constants when we enter the subject, okay. So it is a, y square, b all are constants which will become 0. So this is dou z by dou x when you have plus in between. When you have multiplication in between, see, you have to take the term outside, okay. Like c into x, okay. You can take c outside, okay. So this is dou z by dou x, first derivative. Differentiate z with respect to x partially, okay. Differentiate z with respect to y partially. When you differentiate with respect to y partially, x is constant. So this becomes 0, this becomes 0, this becomes 2y, this becomes 0, okay. So you should know the higher order derivatives. Dou square z by dou x square is dou by dou x of dou z by dou x. Dou square z by dou y square is dou by dou y of dou z by dou y. Dou square z by dou x dou y is dou by dou x of dou z by dou y. Okay. So this is dou square z by dou x dou y. So you should know all these okay. So you can easily do any problem, okay. We shall see problem. Let us see z equal to ax cube plus by cube. Differentiate z with respect to x partially. That is y is constant. A and b are already constants. So this by cube is a constant term. When you differentiate with respect to x, it will become 0. Take a outside. Otherwise you write like this and do. Ax cube plus by cube. Separately, if you want, you can write. When you differentiate this term with respect to x, it will become 0, right? When you differentiate ax cube, take a outside. Differentiate x cube, 3x square, okay, which is 3ax square, okay. If you want second derivative, dou square z by dou x square, which is dou by dou x of dou z by dou x, okay. You have to differentiate the already differentiated, this is 3ax square, okay. Already differentiated this ax cube plus by cube. Okay. So once all differentiated, when you differentiate it again, take 3a outside, differentiate x square 2x, which is 6ax, okay. Similarly, differentiate z with respect to y partially. So what is z? Ax cube plus by cube. Differentiate with respect to y, then x is constant. A and b already constants. So it will become 0, this ax cube. Differentiate by cube with respect to y. Partial differentiation. When you use partial differentiation, the other variable is constant, okay. So take b outside, differentiate this y cube, it is, take b outside, differentiate y cube, it is 3y square. So which is 3by square, okay. So similarly, you can proceed. Let us see another problem. Differentiate z with respect to x. Okay. dou by dou x of with respect to x partially. When we have more than one variable, we have to use the word partially. The word partially says other variables are constant. Ax plus by plus root of a square plus b square. So when you differentiate ax with respect to x, take a outside. X with respect to x is 1. When you differentiate by with respect to x, becomes 0. When you differentiate root of a square plus b square with respect to x, which will become 0. Okay. Become 0 because it is constant, right? Constant. So answer is A. Let us write the question like this. Z is equal to ax plus by plus root of x square plus y square. See, differentiate z with respect to x partially. Dou by dou x of ax plus by plus root of x square plus y square. So when you differentiate this term with respect to x, take a outside. X with respect to x is 1. When you differentiate with respect to x partially, y is constant, b is already constant, which will become 0. Differentiation of constant is 0. When you differentiate root of x square plus y square, you should know this formula. See, d by dx of root x. What is differentiation of root x? Root x is, we know x root, square root is power 1 by 2. X power 1 by 2. Let us use x power in formula. D by dx of x power in formula. N into x power 1 by 2 minus 1. Which is 1 by 2 into x power. 1 by 2 minus 1 is minus 1 by 2. Right? Take LCM to 1 minus 2 by 2. Which is minus 1 by 2. When we have x power minus 1 by 2, let us bring the term down. 1 by 2 into 1 by x power 1 by 2. The power becomes positive when you bring it down. So x power 1 by 2 is root x, right? X power 1 by 2 is root x. So which is root x? Which is 1 by 2 root x. So differentiation of root x is 1 by 2 root x. Okay. Differentiation of root x is 1 by 2 root x. Similarly here, differentiation of this root x is 1 plus in between. Differentiation is 1 by 2 root of x square plus y square. Okay. So when you have root x, when you differentiate it, it will become 1 by 2 root x, right? Similarly here, it will become 1 by 2 this. After differentiating square root part, listen here, you have to differentiate the term inside. Because it is not simply x to leave. Okay. If it is x, when x is differentiated with respect to x, it is 1. But it is different, x square plus y square. After differentiating square root term, differentiate x square plus y square with respect to x. What will we get when you differentiate x square plus y square? Differentiation of x square is 2x. Differentiation of y square is 0. Okay. See, first you differentiate square root of x, which is 1 by 2 root x. Then you differentiate the term after differentiating square root part, leave square root part. Differentiate this part. So here we have not done like that because it is simply x. After differentiating it, when you differentiate x with respect to x, which is 1. That's why we will not do. Okay. That's why we will not say that. But here it is different. Okay. So after differentiating square root x is 1 by 2 root x. Then differentiate this part with respect to x partially, which is 2x. So 2 get cancelled. A plus x by root of x square plus y square. Okay. So similarly, you can try other problems in the book. Okay. Thank you.